Ever wish those transactions on your favorite blockchain platform were just a tad faster? Maybe even a whole lot faster.
It's a common desire, for sure. Everyone's
Right.
looking for that speed boost, especially when it comes to blockchain.
Absolutely. And today we're diving deep into BlockDAG technology, a different approach to blockchain architecture that might just be the key to those faster, smoother transactions we're all craving.
It's definitely an area worth exploring. We're talking about a potential game changer in terms of speed and efficiency.
But before we get into how BlockDAG tackles this, let's make sure we're all on the same page about how a traditional blockchain works and perhaps where it falls a little short.
Sounds good. Back to basics for a bit.
Exactly. So imagine a traditional blockchain like a single line at a busy bank with each person in line representing a block of transactions.
Okay, I can visualize that.
Things move one by one, block by block, very sequential. And while that system ensures things are processed in order and the system stays secure, it can lead to some pretty nasty bottlenecks.
Especially when things get busy.
You got it. We're not talking about a little afternoon rush at the bank here. Bitcoin, for example, can only handle a handful of transactions per second.
How many are we talking, roughly?
We're talking somewhere between the 3 and 7 max.
Wow, that doesn't sound like many.
Not at all. Imagine the lines and the wait times. Not exactly ideal for everyday use.
Definitely not.
Yeah.
So where does BlockDAG come in? How does it address this bottleneck issue?
Well, imagine if instead of that single slow-moving line, we suddenly opened up a bunch of new checkout lanes.
Now we're talking. Everyone wins in that scenario.
Precisely. And that's what BlockDAG does for blockchain. It throws out this single-file line model. Instead of one block at a time, it creates a web of blocks that can be processed simultaneously, leading to, you guessed it, much faster transaction speeds.
Okay, I'm starting to see the appeal here. So instead of that single file line, it's like having multiple tellers working at the same time.
You got it. And that's the key advantage of BlockDAG. It aims to break the trade-off that often exists between speed, security, and decentralization.
Because usually, when you try to speed things up, something else takes a hit.
Exactly. But with BlockDAG, you can potentially increase the number of transactions processed per second without sacrificing the security or decentralization of the network.
And for our listeners at home, that means the potential for blockchain applications that are actually fast and efficient enough for real-world use.
Exactly. We're talking about the potential for near instantaneous transactions, lower fees, and a whole new level of blockchain scalability. Now, that's a pretty compelling case for BlockDAG, but I know our listeners are eager to hear about some real-world examples. Can you tell us about a project that's using this technology in a way that really stands out?
Absolutely. One platform that immediately comes to mind is Taraxa.
Taraxa. Okay, I've heard the name, but I have to admit I'm not super familiar. Give us the rundown.
So Taraxa is a layer 1 blockchain, which means it's built from the ground up with BlockDAG at its core. And get this, they're aiming for 5,000 transactions per second with sub-second block inclusion times.
Hold on. Did you say 5,000 transactions per second?
You heard that right. 5,000.
To put that into perspective, we were just talking about Bitcoin struggling to hit 7.
Exactly. And we're not even done yet. Taraxa also boasts true finality in under 4 seconds.
Okay, break that down for me. What exactly do you mean by block inclusion and true finality? Those aren't exactly terms you hear every day.
Fair enough. Block inclusion refers to how quickly a transaction is added to a block after it's initiated. Think of it like this. You're at the grocery store, you've got your basket full, and you're waiting in line for the cashier.
Okay, I can picture that. Long lines, not fun.
Right. So block inclusion time is like measuring how long it takes to get from the back of the line to actually putting your items on the conveyor belt.
Got it. So the shorter the block inclusion time, the faster you're moving through the checkout.
Precisely. And true finality is the next step.
So is that like when you've paid for your groceries and you're walking out of the store?
Exactly. True finality is when a transaction is set in stone, irreversible, no going back. With Taraxa, they're aiming for that entire process, from getting in line to walking out with your groceries, to take less than 4 seconds.
That's some seriously speedy grocery shopping.
And that's precisely what makes Taraxa's use of BlockDAG so compelling. They're not just talking about incremental improvements. We're talking about speeds that could revolutionize how we use and think about blockchain technology.
Okay, I have to ask, it all sounds almost too good to be true. Are there any downsides to using BlockDAG? After all, it's not exactly the standard model in the blockchain space.
You're right, it's not the standard model, at least, not yet. And to be fair, BlockDAG isn't some kind of magical silver bullet solution. It has its own set of complexities and challenges.
Like what? Give us the lowdown. What are some of the hurdles that developers face when working with this technology?
One of the biggest challenges with any BlockDAG-based platform is ensuring that all those parallel blocks are organized correctly. Remember, we're no longer working with a single linear chain. We're talking about a web of interconnected blocks, and things can get messy quickly.
Makes sense. It's one thing to have multiple checkout lanes open, but you need a system to make sure everyone gets through in the right order and no one cuts in line.
Exactly. And then there's the challenge of finality. With parallel processing, guaranteeing that transactions are truly final and irreversible is much more complex than with a traditional blockchain.
Right, because if you're processing multiple blocks at the same time, how do you make sure they don't conflict with each other? How do you prevent double spending or other issues that could undermine the integrity of the entire system?
You've hit the nail on the head. And finally, there's the challenge of preventing spam. If anyone can add blocks to the network at any time, wouldn't that create a whole new set of problems?
It's like those self-checkout lines at the grocery store, great in theory, but they always seem to have someone struggling to scan a bag of grapes, bringing the whole system to a grinding halt.
It's a good analogy. And in the context of blockchain, that struggling to scan a bag of grapes could translate to malicious actors trying to overload the network with useless blocks, essentially clogging up the system and slowing everything down.
So it sounds like while BlockDAG offers a lot of potential advantages, there are also some significant technical challenges to overcome.
Absolutely. But what makes projects like Taraxa so interesting is that they're actively developing solutions to these challenges. They're not just talking about the theory of BlockDAG, they're putting it into practice.
So they're kind of like the trailblazers paving the way for wider adoption of this technology.
Exactly. But before we get too deep into the weeds with Taraxa, remember I mentioned there's another project out there leveraging BlockDAG.
Oh, right. Kaspa. You piqued my curiosity earlier. What's their take on all of this? Okay, refresh my memory. How does Kaspa approach BlockDAG, and what sets them apart in this space?
Well, if speed is what gets you going, Kaspa is certainly pushing the boundaries. Think one new block added every single second.
Wow, a block a second. That's incredible. For our listeners who might not immediately grasp the significance of that, can you put that into perspective?
Sure. With something like Bitcoin, you're often looking at a 10-minute wait, sometimes even longer, just for a single transaction to be confirmed. On Kaspa, that confirmation happens in seconds.
Okay, that's a huge difference. So for someone who's interested in actually using blockchain technology for everyday transactions, that kind of speed is a game changer.
Absolutely. It opens up a whole world of possibilities that simply aren't feasible with slower blockchains.
Now, I have to imagine that kind of speed comes with its own set of challenges. How does Kaspa ensure the security and reliability of its network while maintaining such a high transaction throughput?
Well, they've made some interesting architectural choices. One thing they're doing is a complete rewrite of their code base in the Rust programming language.
Ah, Rust. I've heard a lot of good things about Rust, especially when it comes to building secure and efficient systems.
It's true, Rust is gaining a lot of traction in the blockchain world. And for Kaspa, this rewrite is about more than just speed. It's also laying the groundwork for them to introduce smart contracts.
Smart contracts on a high-speed, scalable platform like Kaspa, that's a pretty potent combination.
Exactly. And it speaks to the broader potential of BlockDAG technology. We're talking about platforms that could potentially handle the same volume of transactions as some of the biggest players in the financial world.
It's pretty mind-blowing when you think about it. But here's the question that's been at the back of my mind throughout this entire conversation. If BlockDAG is so promising, if it has the potential to solve so many of the problems that have been plaguing blockchain development for years, why hasn't it become more mainstream? What's holding it back?
Well, for starters, BlockDAG technology is still relatively new compared to traditional blockchains. There's always a learning curve with new tech, and this one is no exception.
So part of it is just a matter of time and familiarity.
Exactly. And while projects like Taraxa and Kaspa are doing fantastic work, we still need more developers to really dig in, understand the nuances of BlockDAG, and contribute to its development.
It's like any emerging technology. It takes a critical mass of people to move it from the fringes to the mainstream.
Right. But it's more than just about getting people up to speed. There's also the need for more robust and standardized tools and infrastructure.
Because right now, it's kind of like the Wild West out there.
In a way, yes. But the good news is that the BlockDAG community is incredibly passionate and collaborative. There's a lot of shared knowledge and a real spirit of working together to push this technology forward.
That's what's always excited me about the blockchain space, the sense of community, the willingness to experiment, and the constant drive to innovate. So while BlockDAG might not be a household name just yet, it certainly seems like it's on the right track.
Absolutely. And for our listeners, that means there's still time to get in on the ground floor. Explore projects like Taraxa and Kaspa, dive into the technical details, and who knows, maybe you'll be the one to develop that killer app that takes BlockDAG from promising technology to global phenomenon.
Now that's a challenge I can get behind. Well, folks, that wraps up our deep dive into the world of BlockDAG. We hope you found this exploration as fascinating as we did.
It's been a pleasure, as always.
Until next time, keep exploring, keep learning, and most importantly, keep believing in the power of technology to change the world.